welcome everyone. My name is Natan Silnitsky, and I'm a backend infrastructure team lead at Wix.com. And during most of 2021, my team at Wix worked on migrating our more than 2,000 microservices at Wix from self-hosted Kafka clusters to managed Kafka cloud platform. And this has been the most challenging project I've ever led. So today I want to share with you some key design decisions we took for such migrations, some war stories about stuff that went wrong in production, and also some best practices for you to have when dealing with such migrations. First, a few words about Wix. So Wix is a website building platform that also allows you to manage your business online. So you get everything from bookings to drop shipping, and you can have a site automatically sprung up for you, or on the other hand, complete custom expert design that you can do. And our mission is to enable any business, community, or person on earth to make their online dreams come true. So that's a high and lofty goal. And we have around 5,000 people working on achieving the goal of having everyone's online dreams come true. Around 100 million websites have been published by Wix users. So that's around 6% of all internet websites, which is roughly 1.7 billion. Interesting number there. And around 1 billion unique visitors visit the Wix platform, so Wix sites and also mobile apps every single month. And Wix scale is quite large. We have 500 billion daily HTTP requests, and also a lot of Kafka traffic that I'll show you in a bit, and 18 data centers and points of presence all around the world. So such a huge operation that spans all possible website verticals you can think about, and open platform for plugins on top requires a lot of different services, and they have a lot of interaction between them utilizing Kafka and the event-driven programming style. In terms of locations of Wix engineering, so we have offices in Israel, in Ukraine, so that whole operation mostly moved to Poland, where we also have offices, and in Lithuania, Germany, and a new office in Amsterdam in the Netherlands. So in terms of our Kafka usage, back in 2019, it really wasn't having any engineering challenges for us. Around 5,000 topics with 45,000 partitions, and around 500 million messages produced every day in each of the clusters, so single cluster per region. But last year, we started seeing much more growth in usage, and it keeps on growing in very big numbers today as well. So last year, we already had 20,000 topics per cluster with more than 200,000 partitions and 3 billion messages produced every day. So that meant that the cluster became overloaded above the recommended limit for a single Kafka cluster to have. And we started seeing issues. We saw restarting brokers took a long time. It fell down because all of the back and forth with Zookeeper and the too much metadata to handle, basically, and real production impact. So our decision was to first split up the clusters to multiple ones, to shard them, and also importantly to move to a managed Kafka platform in order to gain the following benefits. So we have better cluster performance and flexibility. The focus of our DevOps wasn't really on making sure that Kafka is up to date and healthy, perfectly balanced brokers. It's something that needs to be monitored and tracked and done all the time, and you need a really pretty expert DevOps team to do stuff like that with the rebalancing of brokers and such. So having that on managed specifically on Confluent Cloud was our choice, meant we get automatic balanced clusters, and Kafka versions upgrade, which can be risky, is done not by us, by the managed platform. It's really as easy to add a new cluster. And also, Confluent Cloud offers tiered storage. So that meant that we no longer need to worry about how many events we keep historically. We can keep a lot more, and it's really cost effective. It goes to S3 and stuff like that. So that's a big advantage moving to managed as well. Now, specifically at Wix, we don't use Kafka SDK directly. We have our own wrapper on top called Greyhound, which is our own abstraction for event-driven style produce consume. And we have Greyhound producer on top of a Kafka producer and Greyhound consumer on top of Kafka consumer, which really helped us in the migration that we will see in a bit. So yeah, so a lot of microservices use this for event processing. Checkout service produces, and then payment service consumes, does the payment and sends off the response via WebSocket to the browser. And the API for our developers is really simple. So Greyhound consumer spec, topic, group, and then you just specify your custom handling code, and setting up producers also as easy as that. And you don't need to specify what's the addresses and keys. Everything is managed behind the scenes for you with permissions and stuff like that. So it's really fast bootstrapping for any new service at Wix. So the talk is about 3 parts here. We have the multi-cluster, how to decide to shard, and how developers use it. Then the migration itself. Design, architecture, decisions we needed to take here according to our use case, and some best practices that we gained following that migration, and what to expect when you actually perform the migration, some war stories, and also a peek at the future that the migration infrastructure brought us. So like I mentioned, each cluster, we had a single cluster in each region data center. We don't share clusters among different data centers because the latency won't be good. So all the local microservice interaction was done on a single cluster and became overloaded. So then when we decided to shard the experience, we needed to think how to do that. The most important thing was to reduce blast radius. So we have a cluster for the editing and publishing of a site, everything up to do with that. And if you have more site visiting interactions with the site, that's completely different flow. That interaction is on a different Kafka cluster, just to make sure that if one cluster goes wrong, then not the entire Wix platform blows up. And different data centers have different deployments depending on which flows they serve. Now, the developer needs to choose which cluster it needs to produce or consume from. And in a multi-cluster environment, it becomes a bit more complex. Specifically, we decided that the developer will specify a cluster in order to have the possibility to have the same topic name in in all the clusters and not have like automatic resolution. We may revisit it in the future, but that's the current decision. And we have a logical cluster name that makes sense for our developers to use, and they just specify it in the spec and they are done with it. And if they want to say, okay, I want to consume a topic, but wait, which cluster is it? I'm not sure. They go to our custom-built control plane, Kafka control plane, and they look up the topic, and they can see in each data center and cluster where does the topic reside. Okay, so we're quite pleased with our clustering architecture. And we needed to actually move all of the events to our new target clusters. How did we do that? So, like I mentioned before, we had unbalanced brokers. We didn't have the expertise to do it. Unclear Kafka strategy. Do we invest heavily in splitting up and building everything by ourselves or not? Too many partitions and real production impact. So we decided we go the manage route and we need to migrate. So how do we actually migrate? We thought first to completely drain out all the traffic from the data center so that it will be just a simple switch. You produced to this cluster, now you're producing to that cluster. Nothing more to do or consume. But we ended up canceling these plans because several teams at Wix told us it's going to be difficult for us to completely drain some of the data centers because we rely on mostly being there and not in other data centers. So that will mean to do special dedicated work just for that. And also, okay, you're switching the consumers and producers, and what now? Just hope for the best when the traffic returns. So we probably would end up doing a lot of manual testing to making sure the entire data center still operates well, and that can take a long time. And then there's some problem in another data center. The traffic has to move back to the data center we're currently working on. That can really be risky because it's not a gradual migration. You just do all at once. So and there could be all kinds of other edge cases we didn't think about and big blast radius. So we canceled it and said, okay, we'll migrate with regular traffic going into the data center and needs to be handled with the same SLAs and the same good latencies. So we knew that it's going to be more complex, but it has to be seamless and really easy to run, and also production safe, meaning that the traffic is flowing, but we want to have no message loss and as much as possible, no duplicate processing whatsoever. So we knew that we'll need to have as much automation of the process as possible. We have more than 2,000 microservices, and it needs to be really easy to run. So we could utilize the fact that all the services actually use Greyhound. We have Greyhound as a JVM library for JVM services and as a proxy service for non-JVM languages. So we have a complete coverage for all the services at Wix. And we can utilize that. We can actually change stuff in Greyhound in order to perform the migration. So what did we actually do? We understood that in order to switch a consumer without losing any information, we first need to replicate the data by a separate replication service to the target managed clusters, and only then we will be able to safely migrate the consumers. So we built a dedicated migration replication service, and it consumes the data from the events from the source target and produces them into the same partition in the target cluster, while also keeping the offsets mapped between the source and target clusters for each partition in order for the consumer to be able to actually start off from the first offset that it hasn't committed yet in the source cluster. So this gives us the ability to have a seamless migration without losing any data and without doing any double processing. So we also built a migration orchestrator to handle everything for us, interactions with the replication service and with Greyhound. So what was the flow here? First, we got a bunch of topics, usually by some division at Wix, and then we scanned to see all the consumer groups for these topics, and then we need to scan all the topics that these consumer groups consume, because you cannot switch part of the topics that a consumer group consumes. So now you have a bigger set of topics, and that is being replicated. And now the migration orchestration service actually sends out a command to Greyhound. Listen, I want you to, for these topics and for these consumer groups, to unsubscribe from the source cluster. Then Greyhound does that. The migrations orchestrator then verifies that no pod is left consuming and subscribing from the source cluster. And once that is verified, it then moves on automatically to ask Greyhound to start subscribing to the target cluster, and it also provides it the delta for each partition to actually switch. So if we had 57 offset last committed, then Greyhound consumer will just do minus 52 and get to the correct offset 5 in the target cluster. And very importantly, we have the ability to roll back. So it's there could be something going wrong, especially in the first services that you work on, the first topics. So having the ability to roll back and go to the self-hosted cluster was critical. And we did need to do that several times. And in that situation, there was a bit duplicate processing, but it's better than continuing having lag. And it's like the first rule of production, rollback. Okay, so a few best practices that we gathered during migrations that we did. First, create a script that invokes the desired topics to migrate and that checks the state continuously by itself in order to reduce the manual work that's needed to be done when you run it. And if for some reason some state is not what was supposed to happen, then the script stops and alerts on that, and whoever runs the script can check and decide what to do. There are options we did like several rollback options in the script to make sure that production is safe. We decided not to do like auto healing here because human being will be have better knowledge exactly what went wrong and what is the best remediation to choose. But we did do the remediation options quite easily available, including rolling back, of course, the consumer, like I mentioned before. And so that worked usually really, really well with much less production impact. Now, you want to start off, of course, with test topics, not to have real production impact at the beginning. In order to make them substantial, you can relay real topics, put them into the data into the test topics and migrate them. And at least like that, you have real production traffic and you can check the performance of the migration and no lag is building up and stuff like that. Then you can start off with less impactful topics according to your user impact. Think about even if a topic has a massive throughput, if it doesn't affect your users, your customers, you can still do it at the beginning. It's all a matter of not hurting your important business KPIs. And also very importantly, not just say, oh, okay, we have our regular Kafka dashboards and we look there. No, create dedicated migration dashboards and check. So we had a bunch of topics and we clicked a button and we got dashboard with only the topics that we are migrating. And we can see as the producer switch the cluster in Grafana or the consumer. And we can immediately see if something is wrong in just a few seconds. Okay, so we talked a little bit about migration design and best practices. Now let's see a little bit war stories and some stuff that happened in our production that really scared us. So during late last year, we were working with our replicator service, and it started replicating a lot of topics, and stopping replication couldn't be done usually very fast because in order to stop replication, you first need to see that all the consumer groups of a topic in all the divisions of Wix have migrated, and that the producer of the topic has migrated, and only then you can start the replication. So that was a process that took time. So we had more and more topics being part of the replication service with the consumer group, and it became a bottleneck. And we actually, at some point, experienced that replicators stopped consuming messages from the source cluster with some obscure error here, error from the sync group. And a lag was starting to build up with the replication, meaning that the producers that were not migrated yet, that the consumers they didn't see any lag on the target cluster, but migrated consumer started to suffer indirect lag because of the replication service. So that was really a frightening situation. Thankfully, one person in the team found out or knew that this error means that there's a problem in the protocol between the Kafka consumer client and the Kafka broker. Basically, it doesn't have enough message size to actually tell these are all the partitions I want to subscribe to. It was too big. So we just increased the message max bytes dynamically with the Kafka configs CLI, and it solved the problem. And no more errands from sync group, and the lag went away, and we were happy. But then came Christmas Eve 2021, and it just happened again. The same exact problem. But we said, that's not a problem. All we have to do is increase the message max bytes, right? So we increase it from 4 megabytes to 8 megabytes. And it seemed to work until something else started happening. Kafka records started miraculously getting deleted much faster than expected, especially for compact topics. So those are topics that you can load into database or memory and act as a key value storage. So if data is deleted there, it means you have like a database that is gone. So that was really scary. Fortunately, we didn't do the change to 8 megabytes for all of our data centers at once. We kept one to see how it goes. So we were able to recover that data for these Kafka databases from that data center to the other data centers. So that was really lucky for us. So the user impact was meaningful but short-lived. And then we went and looked for what is causing these deletions. So we saw this bug in Kafka for quite a lot of versions, where if you change the Kafka broker configuration dynamically twice, then it reverts the log configuration to default. So log configuration is default, meaning that any topic configuration, including the cleanup policy compact, is ignored, and it just goes to the default broker settings for log. So that's why the records kept on getting deleted. So in order to solve this, we decided to change just a dummy value for all of the topic configurations to make sure that they no longer check the default, and that stabilizes things. And we also decided to stop touching dynamic configuration with the Kafka broker CLI, and just did sharding with the consumer groups in the replicator service. So we just introduced a new consumer group for a new batch of topics to replicate, and with a copy of the service. So we sharded the replicator service basically, and that solved the issue, and the migration went on successfully for completion. Now, we finished the migration successfully. We're very happy, and we noticed that we have a way to actually control Kafka client behavior from outside the service, because we're sending commands to Greyhound to do stuff for us. So we thought, okay, we have plans to utilize this to tell the grand consumer or producer to switch to a different cluster in a safe manner, or to skip messages and seek to a new offset in order to avoid some corrupted data, or change processing rate in each of the pods because the developer notices that there's a problem with the database, or the database is too slow and it wants to reduce the effect on the database. And all of this we can do without GAing the service, changing any code. We just send out commands to Greyhound with the infrastructure we built in place. So really excited about that. And to summarize, we used our own Kafka infrastructure Greyhound and dedicated orchestration services to have automatic as possible migration that is safe, except for the times that we had the user impact, but it was really rare, and a gradual safe migration that we were pleased with the result, because 95% of the developers didn't even notice that we did this migration, which was really a great achievement. And if you want to get more details on the migration, I wrote a blog post on it, and you can find this is the link, but I also share a link for the slides in a little bit, so you don't have to worry about the links here. And Greyhound is open source, like I mentioned, and it offers all kinds of features for deciding on the processing rate in each of your pods, how much parallel processing you want to do, and all kinds of retry mechanisms for your consumers and producers to make sure that you have a resilient, distributed, event-driven environment that's, at the end of the day, successfully processes messages. And I recommend for you to check it out. And this is the link I told you in SlideShare, where you can find the slides and the links for the talk. And I want to thank you very much. And also recommend for you to check out my website, natansil.com, where you'll find previous talks I gave in conferences on Kafka, event-driven architecture, and other software engineering topics, and also blog posts I've written on that. And you can follow me on Twitter and LinkedIn to catch up on everything our team at Wix is doing around Kafka, around event-driven architecture, around caches as well, DynamoDB, and maybe other topics soon as well. So thank you very much again. If there are any questions, I would be happy to answer.
Hi. I was wondering, your migrator service, is that one process per topic, or is it a process per application? How do you kind of structure it that way?
Dividing the migration, you mean?
Yeah, exactly. So if you get one that's run away, how do I kill it?
Right. Okay. So we knew that we wanted to, if there's a problem, to limit the issue to a certain area at Wix. So we usually went in and checked what are the topics that are consumed by the restaurants vertical or the bookings vertical, stuff like that, and we focused on that. Now the migration service sends out commands to Greyhound, and you say, what if Greyhound runs away, you mean? Well, basically, there is the Kafka event that you send, but there is also polling done, not only listening to events. It's all actually done with DynamoDB database and events. So we put something in the database by the migration service, and then an event shoots up, Greyhound listens to it, and says, oh, okay, I need to switch. And then something goes wrong. So in worst case, we can change the value in the database and just restart the service, and then everything goes back to normal. But usually there wasn't any runoff. Usually it's just if there is some logical error, then the rollback, we turned on the rollback, and Greyhound switched back to the self-hosted cluster, and there was duplicate processing, but it worked out fine.
Hi. Do you use schema registry, and how did you migrate them also on the new cluster?
Okay, so we don't use schema registry. We have our protobuf based schema, I would say, and it is all the protobuf is sent to a centralized documentation service and stuff like that. We chose that because we are also a gRPC shop, not only Kafka, and all that together works really well. gRPC plus events with protobuf, and but that is orthogonal to which clusters the topic is found on, because it's a distributed thing. You can see the protobuf documentation, and you import a Bazel target. We work with the Bazel build tool, and you will get the definition of the proto, and you can consume it. But because we didn't use schema registry, we didn't face any difficulty in that area. Thank God.
I have two questions. The first one is you said the message size was 8 megabytes, right? That's what it showed?
The message max bytes value for the protocol between broker and produce group, we increased it from 4 megabytes to 8 megabytes.
Yeah, that sounds like a lot. I mean, what exactly does it contain that it reaches 8 megabytes? Because usually it should be like hundreds of kilobytes,
Right.
right?
Right. So 4 megabytes was something that we passed. I don't know if we would have gone to the entire 8 megabytes, but basically you have the replicator service. And it has multiple pods. And in each pod, you want to subscribe for thousands upon thousands of partitions. And we didn't put TCP tracing or something like that, but we saw that once we hit a certain amount of partitions, then this error occurred.
Okay. Second question, you said that your cluster was on-prem before?
Correct.
And you moved to a cloud-managed Kafka?
Correct.
Did you have any problems with network latency after you, because I'm guessing that your apps are not running in the cloud if you had an on-prem cluster, right?
No, when I mean on-prem, I mean it's we have our own setup of Kafka on AWS.
Oh, okay. So it's not really on-prem servers. It's in AWS anyway.
Correct.
Okay. Thank you.
Yeah. If I said on-premise, I should have said self-hosted. But I don't know. How do you say that when you have when you deploy something on the cloud? It's not managed. I mean, so a bit of overloading on the name.
So my question is, the replicator service, was that a product of Confluent that you used, or is it something that you at Wix or your teams built yourselves?
Right. So we actually don't use Mirror Maker. We have our own region cross DC replication service that we created. We use Greyhound. We use batch consumer of Greyhound that allows to do really fast, to have really fast and big throughput. It was like historically, the first Mirror Maker version didn't give us everything we wanted, and I think it was not good enough. I think they really improved with Mirror Maker 2. But because we have really a lot of experience with that, we decided to do our own custom service for the migration as well. If you notice, we kept the offsets mapped. I think Mirror Maker or something like that has some feature about offsets as well, but we haven't investigated that fully. It may have been an option here as well to use Mirror Maker, and even for it to know which offsets to move. But I'm not sure it would have helped with actually switching the consumer. We needed to fetch that information in order to help the consumer do the switch. So I can't say.
You talked about that error that you fixed by increasing the max message bytes. Was there anything that you needed to do to recover any data that was lost? I mean, the fix would stop the error, but was there anything that you need to do to recover any data?
Yeah, so fortunately for us, we didn't do that change in all the data centers. We kept one of the big ones without the change. And for these compacted topics, almost always there is replication for all data centers, meaning that there's exact identical values for all of them. So what we needed to do was to replicate the data back to all the clusters that got the records deleted. Now we had an issue there that usually when we replicate, we see, okay, this data came from another data center, so I'm not gonna use it in order to avoid cycles. But in this case, we actually needed to have all the data, no matter where it came from, because we were in crisis mode, because the messages were deleted. So we needed to do a different algorithm to say, no matter what was the origin data center of the original data, we need all of them from the data center that remained intact, and get all of that and put it and fix the other data centers. I hope I was clear on that.
Yeah, hi. Are you happy with how AWS are managing Kafka for you? Do you think they know what they're doing?
Well, we chosen Confluent Cloud, and Confluent is the company that has most contribution to the Kafka open source code base. So they are the real, say, Kafka experts. I would say that their SaaS solution is still not perfect. We actually gave them a lot of feedback, and they're really responding really fast for fixing stuff. For instance, there was an issue that the cluster was not balanced, so we paid for more capacity, but it was a situation where we have high commit rate for our consumer groups. So the consumer offsets topic became huge in one broker in Confluent Cloud. So they need to fix to automatically have rebalance in place for the consumer offsets topic in order to rebalance and stuff like that. But overall, we're pleased because, like I mentioned, it's really easy to add more clusters, and they have the tiered storage, and they're also working on broker side filtering for Confluent Cloud, which is, as Wix keeps growing, we have a lot of generic topics that are interested to many different parties, but they want a small chunks of the events happening there. We have a lot of different use cases like that. So instead of having the consumer client side keep filtering, if you have it on a broker, you can save a lot of throughput and a lot of network. So really excited about that upcoming feature. And actually, I think Confluent now is in a position that they need to see what are they giving to the open source and what are they giving to Confluent Platform and Confluent Cloud. But I think their strategy is first in the cloud and like a year later in open source, something like that. So I guess it's a win for us to get it early. Okay, if there are any more questions, I would like to thank you again, and you can reach me in the conference after this talk, and also on Twitter I'm open for DMs. So thanks again.